Hello, everybody. Good morning. My name is Todd Muirhead. David Morris, who is also supposed to be presenting this, is not going to be here today, so I'm going to be covering the whole presentation, which leads me to a funny story I want to start off with. So I was talking with one of my friends who presented earlier this week, and he was filling in for somebody, and there was also two names on the deck, but it was just him. And so when he got the survey results, he actually was polled at performing worse than the guy who wasn't even there. So my main goal for today is to beat David in the poll, or at least not get worse. So I'm Todd. We'll both be in the survey, but hopefully you'll remember who was here and who wasn't. So we're going to be talking about monster database VM performance, specifically SQL Server and Oracle testing and results that we've done. We'll talk a little bit about best practices and key findings as we go. So this is the results of an internal VMware survey of our customers. And the main takeaway here is that while a few years ago, or maybe more than a few years ago, a lot of customers were really hesitant to virtualize some of their mission-critical databases. Today, it's become rather common. So SQL Server is at the top of the list of mission-critical applications that have been virtualized. And then Oracle is also fairly high up in the list. And you see the others in here as well. So the point is that lots of people are doing this now. It works really well. And today, we're going to talk about pushing the boundaries into the really big stuff. So there are a lot of sessions and different resources that are available to you. I just want to point out here that the Oracle user group has a VMware special interest group that you can join. So you can be with your peers that are also doing the same type of virtualization of databases, Oracle specifically, and learn more in that group. We also are going to be at Oracle VMworld here in a couple of weeks. So if anybody's going to be also attending that, VMware will be there as well. We've had some books published over the last few years. This is showing SQL Server and Oracle books, virtualizing those databases on VMware. There's tons of great information, way more detail than I'm going to be able to get into in an hour. And if you're really serious about doing this, getting into the depths, both of these books are great resources to have. Okay, so this is kind of a brief outline of what we're going to cover. Basically, we're going to do a little intro on monster VMs, what that means in vSphere 6. Then I'm going to talk about the testing overview, what workload we used, the test bed layout, use the same test bed or almost the same test bed for Oracle and SQL testing. Then we'll talk about the results from SQL Server first, then Oracle, and then we'll wrap it up with key findings, best practices types of things. I am going to try to finish early, about 5 to 10 minutes early, so that we have time for questions. So if you think of a question, be sure and ask it at the end, and I'll do my best to answer. Okay, so I forgot to introduce myself. So I'm an engineer in the VMware Performance Engineering Group. I've been there for about 7 years, working mostly on database virtualization and performance characterization and testing. My goal is to test things out, figure out where the problems are, and either fix them in our product, identify ways in terms of settings or best practices to overcome those things. So when I started 7 years ago, there was a lot of things that we really had to figure out and develop. Things were a lot more difficult to do. The size of VMs was fairly limited in terms of relative to what databases needed. Today, my job is a lot easier in a lot of ways. We are able to scale to much bigger sizes and handle much bigger things. We've figured out how to handle databases for the most part, and the product's been improved vastly from 7 years ago, where we can do much better job in terms of a lot of things, I/O performance. We've got virtual NUMA. All these things all add up to really much better platform for virtualizing these large databases. Okay, so monster VMs are set free. So we have this picture of Godzilla to represent something really big, and it's a monster too. So this is really in my view, the big feature in vSphere 6 was that we increased the size of the VMs. So in 5.5, we were able to go up to 64 vCPUs and 1 terabyte, and with 6.0, we can now go to 128 vCPUs and 4 terabytes of memory. And this really broadens the scope of what we're able to support. And specifically, this is aimed at large databases mostly. This is where we mostly see these really large VMs being used. There's not really a whole lot of other use cases that would really need this scale. So from a virtual database point of view, this has been a really big thing for us with 6.0. We want to allow customers to be able to run even their biggest databases on top of vSphere and do it well. Which comes into what we're going to talk about today. We actually did a lot of testing specifically on the high end with the really large number of vCPUs and memory counts to show that yes, you can indeed get good performance as you go up to these new sizes that we support. So first I'm going to talk just for a couple of minutes about the workload that we used for the tests. It's a DVD store. This is an open source benchmark that I created with a coworker of mine a while back. We've continued to update it. It's been around for a little over 10 years now. It simulates an online store that sells DVDs. So customers in this DVD store can log in, browse products, make purchases, and also sign up for like to be a new customer. Along the way, we use a lot of we try to use all of the common database functionalities, triggers, stored procedures, primary and foreign keys. What else? We try to use everything. We've got lots of indexes. We've got support for all four. I say all four. For four of the databases, SQL Server and Oracle, which are the two that I'm going to be talking about today. We also support MySQL and Postgres as well. The workload's been used by a lot of partners. And we use it a lot at VMware, both internally and in external-facing talks like today. But it's also been used by Dell and Cisco. Principal Technologies uses it in a lot of their papers. It's a fairly commonly used benchmark. It is designed to stress the CPU and to show that with a real database workload that does have back-end real disk that you have to have in order to be able to process all of this, but what kind of performance you can get as you continue to add CPU onto your host. So it works really well when we do these different tests where you're going to compare one server versus another, or different size VMs versus other size VMs. It works really well for that. Okay, so it's open source. If you want it, it's on GitHub, and my email address is there, and if you email me, I'll even help you to get it up and running if you're so inclined. So DVD Store 2 comes in, there's three standard sizes. There's a small size, which is basically just to use, to get it up and running, make sure that it all works. It's really tiny, only 10 megabytes. The medium size is 1 gig, and then the large size is 100 gig. In the SQL Server test, we use the 100 gig size. We also support, there's scripts that allow you to create any size you want. So while those are the three standard sizes, you can go in and tell it, I want 20 gig or 50 gig or whatever the size that you want, and then it'll generate the scripts to build such a database. So in the Oracle testing, we actually use a slightly smaller size. I believe it was 25 gig. And so then one of the things is that in order to really saturate these big database VMs where we have 64, 128 vCPUs, we end up having to run multiple instances of the DVD store within a single guest. Because it just, it has, the DVD store itself has problems with scaling up to really saturate that many processors at a time. So we run multiple instances within a single VM in some cases. Which means, like for the SQL Server, for example, 64 vCPU had 4 100 gigabyte instances, so it was using 400 gigabyte working set for that test. So this is the test bed layout. We used a 4-socket server. This is Ivy Bridge. Dell PowerEdge R920 in this case. We were using vSphere 6, of course, so we could do the big VMs all the way up to 120 vCPU, 128 vCPU. On the back end, we have a EMC VNX a VNX storage array that has some SSDs in it, 30 SSDs, and it has another 70 spinning drives as well. So most of our data was on the SSDs, so we get the best performance. And then we had a client load driver system. This is a 2-socket server where we had the VMs that were being used to drive the load against the database. So something that's always really important in order to get the best performance out is really understanding the host processor architecture these days. So we have the NUMA architecture on all of the current servers, and it really is good or important to know exactly what your NUMA architecture is for your server, meaning how many cores you have per socket, and then understanding that when you turn on hyperthreading, what happens. So in this case, we're using the Intel E7 4890 version 2 processors, which we call Ivy Bridge EX. There's 4 of them. Each one has 15 cores per processor. But then when you enable hyperthreading, it doubles it. So then you'd have 30 logical threads per socket. So when you multiply that out, that's 60 cores or 120 threads for the whole box. So this works pretty well when we do our large VMs, because we can go up to 120. We can do 120 vCPU VM, and that matches real nice and clean with the server also having 120 threads. So while it's a little, I think it sometimes can be a little confusing what all these threads mean and where they are and how they're numbered. There's a couple of utilities I'm going to talk about in the talk, and this is one of them, that gives you a chance to see in more detail if you're interested. So this is a command that you can run from the ESX command line that will give you the host processor IDs in terms of details of what processor type it is, and then it'll tell you the numbering, so how we are actually numbering these processors, meaning their cores and hyperthreads logically. So this is for the server that we use with 120 threads. When we run this command, we get the 4 processors, and then we get, you can see the 30 threads per processor, per socket. And so what this means is that, so 0 through 29 is the first processor, the first socket, and then you have 30 through 59, 60, etc. So when you want to, so this is leading into one of the questions that we get about, which is about CPU pinning or affinitizing. Sometimes customers have wanted to control this to get what they perceive to be better performance. If you were to attempt something like that and you didn't understand at all what was going on here, like how we had logically numbered these, you can get into really, I mean, it's not a horrible configuration, but you can hurt your performance quite a bit. So by knowing this and understanding where the hyperthreads are at and where the cores are at, it makes more sense as we go and talk about affinitizing and pinning and why you don't want to do that. Okay, so let's look at the SQL Server tests first. So there was a study that we did last year, 2014, and talked about at VMworld last year as well. And it's very similar to the SQL Server tests that I'm going to talk about mostly today. So it makes sense to kind of compare those to kind of show where we are. The big difference between the 2 tests is that we upgraded the host in terms of the software. So we went from vSphere 5.5 to 6.0. We also upgraded the server hardware itself from vSphere EX to Ivy Bridge EX. So it's the next generation of Intel servers. So we went from number of cores per socket being at 10 cores per socket to 15 cores per socket on the host. So it's about a 50% gain in terms of the number of cores that are on the host itself. So we're able to do much larger VMs, which is exactly what we wanted to test out with vSphere 6. So again, it's going to have the 120 vCPUs. So in the previous test, we had to stop at 64 vCPUs but today we're able to test all the way up to 128. So what we looked at a minute ago was the host enumeration of the cores and the hyperthreads. So when we set up our VM, we're giving it virtual CPUs. And we can assign virtual NUMA topology as well. So then when you get into the guest, if you want to see how that has flowed through to the guest, there are some tools that you can use at the guest level to see that as well. So this is a tool from Microsoft that you can run on Windows that will tell you exactly what the NUMA architecture looks like to the guest. It's called Core Info. So it's command line. These are the different options that you could pass it. And when you run it, it gives you an output like this. So it'll show you the physical processor number, and then it gives this little ASCII chart text thing where it shows you where it's at in the NUMA node itself. And then on the bottom here, we see the mapping of the logical processors to each of the NUMA nodes. So we can see we've got 4 logical NUMA nodes inside this VM, and we've got our what they think are physical processors. They're the vCPUs spread across the 4 nodes evenly. So this is exactly what we had presented to the guest in terms of a virtual NUMA layout, and this is what we're seeing. So this is always good. It's not a bad idea to check this just to make sure that you set up your virtual NUMA correctly and that it is all passed through and you're seeing what you expect. There's a similar tool in Linux called, or a similar command in Linux, which is, what is it, NUMA control? No, it's there's a similar command in Linux that will give you the output. And I can't think of the exact name of the command, but you can do this in Linux as well. Okay, so this is a first test result we're going to look at on SQL Server. So we set up the 60 vCPU VM in 2 different ways, and this is to basically illustrate why you don't want to try to do pinning, or why you want to be very careful if you do pinning. So in the first case, the larger bar, we got about 600,000 orders per minute from the DVD store. This is default scheduler behavior. So we just created a 60 vCPU VM with 2 virtual NUMA nodes, and we didn't change anything. We just let the scheduler decide where it was going to put them. So it put all 60 of those vCPUs are running on cores all by themselves. We're not using any of the hyperthreads, right? We're getting full cores. And so we get, like I said, about 600,000. In the second case, we took that same 60 vCPU, but we tried to affinitize it, and we said, we want to pin you to the first 60 threads, the first 60 cores or logical cores that we see in the host. But based on what we saw in the slide a few minutes ago, the first 60 are all on 2 nodes. So you're actually using the hyperthreads in this case. So you're only using 30 cores plus their hyperthreads. And so hyperthreading gives you a little bit of performance boost, but it's not like a full physical core all on its own. So your performance actually ends up being quite a bit lower than what it could be if you were actually using the cores here, just cores, which is the default, so that's good. So we're making the right choices, right? The takeaway is you just want to be careful if you want to do pinning, or if you've heard about that. If you don't do it correctly, you can really hurt yourself, even with the same size VM. Okay, so here's a look this is a look at how we tested the maximum size VMs with SQL Server. So I talked a little bit about how you want to always keep your physical host architecture in mind whenever you're creating your VMs, and try to have that underlying architecture mirrored in the VM as much as possible. So on the top bar, we set up just maximum size VMs. We set them to 128 vCPUs. Let's just make them as big as possible. And we'll run it, and we'll just see what the performance is. So we got pretty good results, 900,000 OPMs for the 8x16 vCPU case, and then drop down a bit when we get to the 2x64. But we're still getting great results. But when you look at where we right-size the VM so that they fit cleanly onto the host, we get better performance. It basically makes things optimized so that the scheduler can make easier choices, so to speak. And we get better results by, a significant, not a huge margin, but a little bit of a significant margin across the board. So in each of these cases, we're running multiple large VMs, right? So 8 of the 16 or 15, and then 4 of the 30 or 32, and then 2 of the 60 or 64. But we're utilizing the whole server in all these cases. So one of the interesting things that I think you probably begin to pick up on is, why is the number so much bigger for when we use multiple smaller VMs? A lot of this is just due to the overhead of the database and the operating system itself. So even in the physical world, if you were to compare like on a throughput on a per CPU basis for a smaller server versus a bigger one, the smaller server tends to be more efficient and get better results. So that's what we're seeing here. Okay, so let's take a look at Oracle now. So the setup was very similar on the hardware side. Like I said, it's the same Ivy Bridge EX host. There are obviously some differences on the virtual machine setup. We are using Linux, CentOS 6.5, which is basically Red Hat Enterprise Edition 6.5. We are using 256 gig, and then per VM, and then we're ranging the number of vCPUs in the VM from 15 up to 120. So with this test, we started with a small VM, then we continued to add additional resources in terms of CPUs to see if we could get the additional performance as we added the additional resources, made the VM bigger and bigger. So that was the main thing that changed in the different configurations. We're using standard database best practices. This is actually the same thing we did with the SQL Server. We're using PV-SCSI adapters, VMXNet 3 adapters inside the guest to get the best performance for both your disk and network. And we're using multiple PV-SCSI adapters. So we're spreading out our data LUNs across as many PV-SCSI adapters as possible. And we did that in an even way. So the logs and the data LUNs are spread out as evenly as possible across the adapters. Again, we're using DVD Store 2 as a workload. Created 8 Oracle instances for each of these VMs. So each VM was running with 8 instances. In order to be able to push the VM at the high end with the 120 vCPUs, we needed to have all 8 there. And, okay. So, test results. So this is the fun part. So on this, there's a few slides of this I'm going to go through, so I'm going to try to go through it slowly to make sure that you can understand why why the data is on different slides. And at the end, I put it all on one slide to show one nice place. So this first slide we used, there's no hyperthreading involved on this slide. So this is just using just the cores without hyperthreads, because hyperthreads makes the math a little funny when you look at the comparisons. So when we do a 15 vCPU VM, we achieved about 100,000 orders per minute. And then we get a near linear increase as we go up to 30, 45, and then 60. We don't quite hit the 400,000. I think it's like at 375 or something. But it's really pretty nice scalability as we continue to add those additional CPUs to the VM to show that even in the 60 vCPU case, in this case, we're able to continue to get additional performance. So 60 vCPUs is exactly equal to the number of physical cores in the box, right? So that matches exactly with the host very cleanly. We have the 15, 30, 45, that matches with each of the different, with each socket, right? So as we went up, we were basically adding an additional socket of server performance to the VM with the additional cores. So the other important thing to note is that in all these tests, the CPU is very near maximum. It was around 95 to 98% utilization in all the tests. So this wasn't taken at a lower level and then something nice and easy. No, we went all the way up as high as we could push the VM and get the maximum throughput from our application at these points as well. So in this test, now we're going to use the hyperthreads, okay? So we're going to use all 120 threads on the box. Now when you enable hyperthreading, It's like I said, it's not a full extra core. It's like it's an extra execution path, as they call it. So you get some more performance out of the core, but not a full 100%. We're going to see what the exact gain was on the next slide. So in order to compare my 120 vCPU VM running with all the threads, so 60 cores with their threads, 120 threads, I needed to compare that against a 60 vCPU VM that was also using HyperThreads for basically half of its performance. So we took a 60 vCPU VM and we pinned it, right, forced it to only run on 2 of the sockets. So it's got 30 cores. So this 60 vCPU VM it only has 30 cores plus their HyperThreads. And the other half of the server I didn't let it play on. So it's only getting half of the server. So that makes it a good thing to compare against with our 120 vCPUs. We're using half of the server. In this case, with the pinned 60 vCPUs against the 120 vCPUs that are across the whole server. Okay, so that's a lot of setup. But the main point is that it shows about what we were hoping, that you get essentially double the performance with the 120 vCPU VM versus a similarly configured smaller 60 vCPU VM that's been pinned. Okay. So we did this with what I told you not to do, right, which is CPU affinity. But for testing, a lot of times we use it to have comparison points and to control tests in certain ways. Okay. So this slide lets us take a look at what the effect of hyperthreading is on performance. Right, so I talked about how we did, first set of tests was no hyperthreads, the second set of tests is with hyperthreads. So now we can take a result from those 2 tests and say, oh, well, we can actually measure what was the performance gain by using the hyperthreads on the same size of VM. So in this case, now I have a 60 vCPU VM that is using, that is just using the cores, and then we're comparing it against the 120 vCPU VMs. Now we've added the 60 hyperthreads to this 120 vCPU VM. And we get a 24% gain in performance just by adding the hyperthreads. So this turned out really nicely because this is about what we usually tell customers and what we normally see in other tests. The gain from hyperthreading usually is about 20 to 30% for database type workloads at least. It can vary a lot. We've seen, in some cases, like I've seen some business warehouse examples, for example, where the gain is a lot smaller. But in this case, which is kind of a typical OLTP environment, we saw about a 24% gain with hyperthreading on these big VMs at high load levels. Okay, so this is where I promised I'd put them all on one slide to show you. You can see the kind of the X gain from our baseline, which is one VM with 15 vCPUs. That's basically, the 15 vCPUs is basically one socket without hyperthreading, right? And then as you compare it, as we go up the different numbers, it all worked out really nicely. So the takeaway is this, is that I was able to drive workload from use the same workload on a small VM, then increase it onto bigger VMs and show that we were able to get the performance that we expected, or very close to what we would hope for, even with the bigger VMs. Okay, so we did all that, and it was really cool, and we pushed it both SQL Server, Oracle, and then about 3 weeks before VMworld San Francisco, we got access to some really cool hardware. And we wanted to take that opportunity to push things even further and do some really big VM testing on what I believe is the biggest x86 server available today. This is the HP Superdome X. So this has 16 sockets. So it's the same type of processors as we were using in the other tests, but this is, there's 16 sockets, right? Did I say that? There's 16 instead of 4. So it's 4 times as big as the previous round of testing that I was talking about. So what we decided to do is, well, let's see if we can run 4 120-way VMs all at the same time on one host running vSphere 6, and this would be like the biggest database test that we could think of. And so that's what we did. We used, so that the server was one side of it. We also needed a really high performance SAN array in order to be able to support the amount of IOs we were going to be generating with these 4 massive VMs. So we got an IBM flash from IBM on loan. It has actually has a little more than 20 terabytes, but it's all flash storage, and it's very fast. It was very nice to get to use it for these tests. And then as the load driver system, we actually used one of our 4-socket servers that we were talking about in the previous test as the load driver, just to be able to push the load and get this server all the way up to maximum. So this is probably like my favorite slide in the whole presentation. And I spent a lot of time looking at this screen over the last month or two. This is ESX top when you're looking at the Superdome system. So this has got, so the Superdome has it has 240 cores or 480 threads on the box. So when you open ESX top and you have that many cores and threads, this is what it looks like. And basically you end up with like just a few lines at the bottom in order to be able to see your VMs and stuff that are running. Yeah, you can, so I've got there's four, I don't know if you guys can read up, there's 4 VMs running on the bottom of all that stuff, yeah. So the VM configuration for this test, so our main goal was to do the 420 vCPU VMs, but we also took the opportunity to run it at some smaller sizes like we did in some of the other tests. So we did 8 60-way VMs and 16 30-way VMs, all run at the same time on the host. But we kept the rest of the configuration the same, and it's very similar to the previous round of Oracle testing that I talked about. So we're using PV-SCSI, VMXNet 3, common regular database best practices. I, once again, did not use any pinning. I did use a parameter called prefer-HT, which basically alters the scheduler's default behavior. I'm going to talk about this in some detail in the next couple of slides. So it's not something that you should just all go out and use, but there are cases where it makes sense. So I'm going to try to explain it so that you'll understand when you might want to consider using it. And then, so each of the tested configurations, we had maximum number of CPUs used. So all of the 480 threads and all the combinations are fully allocated. So we had 4 120 vCPU VMs. That was a 480 vCPUs worth of activity going on if you add up all of the VMs. And that's the same as we did the other configurations as well. So in all test cases, we're pushing the whole Superdome server, all 16 sockets, to the maximum configuration. Now, I did a test with 1 VM running to get a baseline so that we could see, is the performance good as we get up to the maximum size? But in all cases, we did push it all the way up, which is cool, right? Okay, so I'm going to talk about prefer-HT and like scheduling and stuff just for a few minutes, and hopefully I can use these pictures to make it clear. So this is an example, and I don't have the full Superdome drawn out because it would be way too many cores and stuff to think about. So this is just an example to illustrate how it works on a hypothetical 2-socket server. So we've got a 2-socket server with 8 cores per socket in this example. We've got physical NUMA node 0 and NUMA node 1. We're running vSphere ESX, and then we have a VM that's created that's just like the physical underlying architecture, which is what we recommend, right? If you're going to make a big VM, you want to make it match the underlying architecture. So we have 8 vCPUs per virtual NUMA node as well. So this all maps very nicely. But there's this thing called hyperthreading, right, that we've been talking about. So each of these physical cores actually looks like 2 logical cores. So I made this cool, I thought this was really cool. I put like a halo around them so they look like they were hyper. Yeah. So anyway, so that's what that means. So those are the hyperthreads. So those aren't the real cores, those are the kind of the hyper cores. Okay, so whenever we do this is the default behavior of the scheduler. So what it wants to do is it wants to run 1 virtual CPU per physical core. It wants to use 1 of those threads. That's the default. That's the best behavior. We'll get things running across each of these cores. They'll basically each have a core all to themselves, and this is the best performance. Now obviously, so this is a very clean example. There's just 1 VM running. There's no other VMs running, so it's a very simple decision for the scheduler. In reality, everybody has lots of VMs running, or most of the time you have lots of VMs running on a host. The scheduler is still using this basic goal, right, is how it decides to schedule things. But, so once it's used up all the cores, if there was another VM and it needed to be scheduled, it would start to use the hyperthreads as it needed to. But ideally, we're going to spread things out across cores. But if we use this thing called prefer HT, this is what happens. So we take the same VM, same physical host, everything's the same, but instead of that, we've used prefer HT. And so now, instead of those vCPUs being spread across the cores, they're now preferring to use the hyperthreads instead. So it squishes it down, right, and it says, I want to use all the hyperthreads on a single socket, in this case, instead of spreading it out. So this will reduce the performance of this VM quite a bit, like we saw in the other slides, by not quite 50%, maybe by about 40%, because we're just using the hyperthreads. So, why would you want to do that? And the answer is that now this other socket is completely open. So now you could create another VM and tell it to use prefer HT as well, and it'll get a whole socket all to itself. Right? So this is actually really nice and clean in terms of a scheduling scenario, if you do it this way. But it's assuming that both VMs are going to be pretty busy most of the time, and the advantage that they gain from NUMA locality is going to outweigh the advantage they might gain by occasionally being able to run on real cores versus hyperthreads. So, in a benchmark scenario, or when you're going to do a very high load server, where you know that all the threads are going to be really basically fully utilized most of the time, prefer HT can improve your performance at the whole host level, right? So now both of the VMs are going to be optimized to use, they're going to have the NUMA locality advantage of having all of their vCPUs on the same core as where their memory is, without having to ever cross NUMA node boundaries. And they're going to get to use the hyperthreads. So they get the 20% boost from that. So I did this in these tests with a really big server because I knew we were going to run it really high, and we would need this kind of boost to fix things. I have had customers use this as well in the real world, and it's improved their performance in some cases. So it is a real-world-ish kind of thing, but like I said, you just have to be careful, and I would not go out and run this on all of your VMs all your database VMs by any means. It's only kind of a special case thing. Okay, so we called this project with the Superdome and the IBM Flash system, we call it Project Capstone. We got to work with HP and IBM, and it was actually a really good partnership. IBM was able to give us the flash array in a matter of a few days after we asked for it. HP supported us very strongly with the server side as well, and we were all able to meet together, figure out the plan, and get this thing rolling really quickly so that we could have things ready in time for VMworld. So we used a similar configuration at the software side as what I talked about in the previous test. So we have Red Hat Enterprise Linux 6.5, Oracle 12c again. And then, so I'm going to throw a curveball. Then we use the new version of the DVD store. So, like I said, DVD store's been out for, I think, about 10 or 12 years. And we've updated it. This version 2 has been out for about that long. And we've updated it and kept it going. We've added some features, but it's been the same core schema and operations that have happened. So what's happened over that time is that servers are like a lot faster now than they were. And so we had to do things with DVD Store 2, like run a bunch of instances on a single server in order to be able to drive the CPU usage up all the way. So I went back and enhanced DVD Store, made a new version of it that now includes product reviews, and there's a membership thing. It's kind of like Amazon Prime, but it's, I don't call it that. And what the goal of that was is to, number one, make the application a little bit more like stores are today, where customers do reviews, and they read reviews, and they rate reviews. So all that's now included. And so that's one aspect. The other aspect was to drive up the CPU utilization of the workload, so that now we can have a single DVD Store 3 instance on one of these large 120 vCPU VMs, and it drives the CPU usage all the way up to 100%. So in these tests, I'm using a new version of DVD Store. The orders are much more complex now because there's a lot more activity that goes on. So the overall numbers in terms of orders per minute, it goes way down because the orders are much more complicated now. They're heavier, harder to do. But it is basically the same type of approach and testing. It's just different. Anyway, so the point of that is that the numbers aren't applicable. You can't compare the test from DVD Store 3 versus the test of DVD Store 2 because the orders are different. They're heavier. But we did the same type of testing where we would keep adding threads until we get the server up to 100% utilization and our throughput maximizes. So we get the most possible orders per minute from that host. And that's where we take our measurement. Okay, so now we get to talk about the fun stuff. So these are the results. So we got the big server, 16 sockets. We got DVD Store 3 on it. Started off with one VM with 30 vCPUs. So this is basically one socket on the server, on this big 16 socket server. And as I added additional numbers of these VMs, right? So I go from one 30 vCPU VM to 8 to 16 VMs, so 16 30-way VMs running on a single server, which is pretty cool. We were able to stress it all the way out. And what we saw was we got 89% of linear performance gain as we continue to add these VMs. So we're able to use this really big server really pretty efficiently as we added these VMs and continue to get additional throughput or database performance out of the host. This was about 13,000 IOPS per second. Probably the most interesting thing is our response time with this nice IBM flash array remained at about 0.3 milliseconds for the test. So here we're going to look at this 60 vCPU VM test. So there's going to be 8 of these running in the maximum case. The linear growth actually wasn't as good from 1 to 8, but this is actually where we got the best overall performance. So when you're running 8 of these at once, it actually outperformed when you're running 16 of them, or what we're going to look at in a second ago with the 4 of the 120 vCPUs. I think that the reason for this is partially because the way the Superdome is architected, it's actually 8 two-socket server blades. So when I set this up, each VM is essentially a server blade running. So it gets a nice, very clean division within this hardware system where you kind of max out the performance. So again, a lot of times I think knowing the underlying hardware architecture can help you, tweak the performance to the absolute best if you take that into account. Our IOPS response time, so the IOPS increased a bit, 16,000 IOPS, but response time stayed at 0.3. And then, so this is the one that we wanted to do when we started the test. This is the 4 almost max size VMs all running at the same time at about 100% CPU utilization. We achieved our best scalability actually here, 92% of linear, 3.7x of a single VM. And the IOPS went up to increase about 20,000 IOPS, still 0.3 millisecond response time. So DVD Store, it definitely uses IOPS, and they've got to be low latency or else it's going to affect your performance big time. But it's not a huge IOPS machine. It's not going to produce numbers like Iometer or some other I/O test would. So the key for us was that this latency continues to stay so low, it allows us to push the throughput as high as possible. And the nice thing about this all-flash array was that I basically didn't have to do any configuration. So in the past, like all of the tests I've ever done, we've always spent a lot of time setting up the data LUNs and the log LUNs and really monitoring them and make sure that we're getting the right, or what the latency that we need out of everything. Sometimes we have to, once we figure out it's not right, then you got to go back and change things and try something else. But with this all-flash array, we didn't have to do any of that. We basically just created some LUNs and it worked and the performance was great. So, if you can get one of these all-flash arrays, it's pretty nice. Okay, key findings. So there's a couple things. So SQL Server, for the most part, is auto-tuning. It really does a pretty good job with default settings. For the most part, we did uncover a problem, and this is interesting because in previous versions of SQL Server, this wasn't a problem, but with SQL Server 2012, it decided with the DVD Store that it wanted to do something weird with one of its queries. that it didn't do in previous versions. So we had to go and make this setting change so that it would actually evaluate it correctly, or the way it used to, and give us the right performance. There was also a problem we had with the CAL licensing on the Enterprise Edition was limited to 20 logical processors, so we created the big VMs, over 20 vCPUs. SQL Server wasn't seeing them, so we were only getting up to 20 vCPU worth of performance. So we had to go in and make a, well, I'm sorry, we didn't make a change. We used the Developer Edition for the test because it doesn't have a CAL limitation, so this was a licensing thing. Oh, and I've talked about how to load the large VMs with DVD Store 2. We had to use multiple DVD Store instances to push it all the way up. Oh, and so, yeah, so we did that, and then we bound them to different virtual NICs to make sure the load was all spread out across the system. Oracle. So for the most part, we use standard Oracle type best practices for the database portion. We use VMware best practices for setting up a database, which I've at a very high level talked about. I use the Oracle. Oracle has an installer RPM that will go and set up your Linux using most of their, based on their best practices. So you run this, it sets pretty much everything that you need from an Oracle perspective. So it really speeds things up. It was pretty nice. So one caveat or one thing to think about with Oracle is NUMA support. So we've talked a lot about NUMA today. NUMA is obviously a very big part of performance oftentimes these days. Oracle itself as an application does have NUMA support available. By default, Oracle turns it off. They turn off NUMA. And the reason is they found that, and customers have found for the most part, that Oracle's NUMA support does not improve performance. And in some cases, it can make performance worse. So if you read their official guidance, it says to evaluate using NUMA for their NUMA support for Oracle before you go into production with it, which is exactly right. It might improve your performance. There's a good chance that it won't. So in my case, we evaluated it. It did not improve performance, so we left it off. Interesting note here is that even though Oracle doesn't support NUMA, if you set up, at least I've found, if you set up virtual NUMA in the guest and present it to the guest, that still improves your performance by a little bit. So still go ahead and set up your VM with the virtual sockets and nodes that we've talked about. And there is apparently some optimization probably done at the OS layer that's able to take advantage of that enough to make a little bit of a performance difference. But in Oracle, leave the NUMA off most likely. Linux huge pages, which is large pages, the way we refer to them a lot of times at VMware. It's definitely a big thing that you should do. I enabled it for these tests. I saw about a 5 to 10% performance gain just from using huge pages. So you should definitely use that. Okay, storage can be a problem, right? So we've talked about this a bunch of times. You need to make sure that your storage, often, that's almost always the most common source of performance problems, is some type of storage configuration or misconfiguration. Okay, so this is the key findings. I think I've hit most of these through the talk. We did see a drop-off sometimes when we use the larger VMs. We think that's mostly due to the fact that it's a large VM, just like if you use a large host, you see some kind of drop-off in scalability. Size of VMs to be as close to the NUMA node as possible. So even though powers of 2, we were all kind of programmed that way for a long time because everything was powers of 2. But then Intel started to change up the game a while back, and we had 8 cores per socket. We had 6 cores per socket, and then we had 10, and now we have 15. I think there's 18 in the new Haswell. So that's the number that's more important when you're sizing VMs versus the powers of 2 thing. Okay, you need to take into account your NUMA node size. In order to go to 128 vCPUs, you have to also upgrade the hardware, the virtual hardware, which goes along with vSphere 6. This is version 11. And virtual NUMA defaults are optimal for most cases. So from our testing, we've tested and we found that the default settings for virtual NUMA work the best most of the time. And this last thing, latency sensitivity. So this is a setting that we came out with in 5.5 or 5.1 that is for latency sensitive applications. It does a lot of things to the VM that dedicates some resources. But overall for databases, it's not a good idea. Usually, we did some tests with SQL Server that showed that when we enabled it, it actually decreased our performance. So don't view this as a turbo button. Don't just go enable this on things that you think need more performance. It's specifically designed more for things like voice over IP, stock trading applications, things that are really, truly very latency sensitive and would rather have latency over CPU. Okay. There's a lot of other sessions that we would recommend, other extreme performance series sessions. A lot of these have probably already taken place since it's Thursday. But you can go back and view the, listen to the audio or view the slides online after you get home. Performance hands-on labs. There's several labs in the HOL that have performance aspects. We recommend you go check these out. Labs are still open. And that's it. So we've got to think about 10 minutes or so for questions. So two things. There's a survey. Please go fill it out if you get a chance. And then there is a microphone that they're going to pass around for questions if anybody has any. And that's it. Except for questions. I can't see at all. Okay. Yes?
How are you? Regarding the virtual machines that is running the SQL test, assuming I have 2 socket CPU, each one of them have 18 cores, what's the best option to configure the virtual sockets and the virtual CPU? Let's say I need 20 CPU for this VM. Should I configure it as 2 sockets, 10 per each, or just to have it as one on the same socket?
So you need 20 cores?
20 cores,
15,
yes.
You have a system that has 15 cores per socket?
Yeah.
Okay, so if you really need the 20 cores, right? You really need them?
Yes.
Then you should do 2 10 socket
The 2 10.
cores. But if in reality 15 is enough, you could size it down to 15 and fit it on a single node. So we find a lot of times customers have oversized VMs. So that's the answer.
Okay.
It depends is the answer. That's like always the answer, unfortunately. But yeah.
Well, it depends. Most of the KPs from VMware says not use the sockets and instead of the cores. So it's a bit confusing. So should I do a test before I do it?
So if you use the default settings and you just tell it that you want 20 cores.
Yes.
And you say you want
One socket.
One core per socket.
Okay.
What that does is it will actually configure vNUMA for you to be 10 sockets per core. I'm sorry, 10 cores.
10 cores, yes.
10 cores per socket in the background. So if you use those NUMA tools that we talked about in the guest to go look and see what your virtual NUMA topology is after the fact, that's what you'll see. You'll have 2 sockets of 10 cores each.
Actually, the 2012 from Windows can show you from the task manager now, without using this command.
Okay.
Actually, yeah. All right. Thank you. Thanks.
Okay. Thank you.
So I have a question because I saw that when you were showing like the different sizes of VMs and the number of virtual CPUs, you were using 15 vCPUs, and in total it looked like you were really filling completely your server. So aren't you considering any overhead for the virtualization, virtual switch, and so on?
Okay, so you're saying I'm using all the cores for the server, for the VMs, and I'm not allowing anything for the virtualization? Which is correct. So I didn't set aside any vCPUs for virtualization. And so what happens is that has to come out of, so the hypervisor has to figure that out. And we've got to schedule our worldlets for the networking and the I/O along with the VMs, even though all the CPUs have been consumed, right, by vCPUs. So that's part of what's going on when you see we don't get 100% linear. There's a certain percentage of the performance that's taken away by the hypervisor in order to handle things like networking and I/O. So we actually measured that in some of these tests. I didn't get into the results, but like in the Capstone test, where we run 4 120 vCPUs all at the same time, we're also doing quite a bit of networking. About 1 gigabit worth of my 10 gig pipe was being actively used. And that took about 4 cores worth of performance when we went and looked at the net stats. So there's a definite overhead, right, that's there, and we're paying that. But with such a big system, a lot of times it doesn't show up that much, right, in the overall results. We're able to still perform really well.
But when you dimension, for example, you need to decide how big they will be, then is it better when you completely ignore it? And
so, okay, so we did some tests, and I didn't talk about them. There's a white paper that's coming out that's going to show this. So we did the 4 120 vCPU VMs. We also did a test where we did 4 112 vCPU VMs. So we intentionally left some space left over, and the 112 vCPU VMs slightly outperform the 4 120 because it's a little cleaner for everybody. It's easier for us to schedule the networking and the I/O in that case. So yes, if you were really going to stress out a system all the time, it would be a good idea to leave some cores unassigned in order to be able to handle the extra workload. But, I mean, most of the time people don't actually run their systems at 100% all the time. So for the most part, we say you don't need to worry about that. But when you're going to go up to 100%, you're doing sort of a benchmark or a bake-off type of thing, yes, it can help.
thank you.
Question here?
Provided the version of DVD store is consistent, are the results comparable across databases? So between Oracle and SQL Server or Postgres and MySQL?
So the question is, could you take DVD store 2 results from Oracle or SQL Server
And compare
and
them,
compare them?
provided the version of DVD store is the same all the
Right,
time.
so both DVD store 2 or DVD
Yes.
store 3.
Yeah,
The answer is not really. So
okay.
So I wrote the database code, and they do the same thing, and they both process the same orders. They use the same data set, but there are some differences in the way the stored procedures are implemented, and it's basically and that's mostly due to just the differences in the way that the different database vendors have implemented their stored procedure technology. So you can't just port it. You got to rewrite the whole thing. So in some cases, it's a little different. So we've never tried to make those comparable. Okay. Any other questions? It's hard to see with the light, so, okay. Okay, that's it. If anybody has anything else, I'll kind of hang out here right outside the door if you guys want to ask me anything else.